We're going to work with a few rhombus questions right now. On this first problem, we have angle 1 is equal to 61 degrees, and we're going to find all of the angles. So if that angle is 61, there's a couple of theorems dealing with a rhombus that we should know. We've gone over in class, and first of which I'm going to mention is that the diagonals are perpendicular. So therefore we have 4 right angles all at the center of the rhombus. And the other theorem is that the diagonals bisect each of the opposite vertices, or the opposite angles of the original rhombus. So therefore, if we have a 61-degree angle for angle CBD, angle ABD has to be congruent to that. So therefore, there's another 61-degree angle. Now we can look at something like this right triangle at the top of the diagram, and the angles for any triangle add to equal 180. So if the first two angles are 61 and 90, we can add those two together and get 151 and subtract that from 180, and we get 29 degrees for the angle at the top of that triangle. Or we could have said that the two acute angles for a right triangle are complementary, and we could have subtracted 61 from 90 to also get 29. Then the angle at the top of the rhombus is also being bisected, so the angle represented by x is also 29. The two triangles at the top, triangle AD, I guess that's not labeled, but we'll call it point E, is congruent to the triangle to the right, so therefore the angles have to be congruent, corresponding angles. So therefore, if we have 161-degree angle for the triangle on the right, we have to have an angle of 61 for the triangle on the left. Then that angle is being bisected, meaning angle ADC is being bisected. So if one half of it is 61, the other half is 61. And at the bottom of the diagram, we have a couple of 29-degree angles. Either you find alternate interior angles that are congruent because parallel lines are being intersected by a transversal, or the angles for a triangle add to equal 180. In any case, you get a couple more 29-degree angles. And another rhombus question. We have segment AC is equal to 8. So if the entire diagonal is equal to 8, I'm going to simplify that for this problem, or add to the problem and say the distance to the midpoint, because the diagonals are bisecting each other, that has to be 4, and the distance from B to D is equal to 6. Therefore, this segment that I'm marking off has to be of length 3. Because the diagonals are perpendicular to each other, we can solve for x by using the Pythagorean theorem. So it is a 3, 4, 5 triangle, but if you don't recognize that, you just use the Pythagorean theorem. You say 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. X squared equals 25. And x equals the square root of 25, which is 5. So if x is equal to 5, and it's a rhombus, all of the sides are equal to 5. So BC is equal to 5, CD is equal to 5, and AD is also equal to 5. The perimeter of the rhombus is simply all of those sides added together. 5 plus 5 plus 5 plus 5, or 4 times 5, is equal to 20. Hope that helps. Good luck.